For many years, as we've gazed at the night sky, one celestial riddle has consistently tugged at our collective wonder. It's not about landing on Mars or reaching distant galaxies, but rather a tiny distant world right within our solar neighborhood. Pluto, the cosmic puzzle perched on the edge of our solar system, has always whispered its mystery to us. But what could this little planet be hiding? Join us on a cosmic journey as we embark on a voyage to explore the captivating mystery that surrounds the planet Pluto. But before we proceed, quickly subscribe to our channel and turn on your notification bell so you don't miss out on any of our videos. Let's start. What do you really know about that planet named Pluto? We're sure you've heard quite a little about it, but it was more like a mystery because we didn't have the tools to explore it like we do today. Pluto, the cosmic recluse, resides at a staggering distance of 40 astronomical units from our Sun. It's a peculiar and distant traveler in our solar system, tracing an elongated orbit that defies convention, completing its journey around the Sun every 248 Earth years. Pluto marches to the beat of its cosmic drum. What sets Pluto apart is its size, or rather its lack thereof. With a radius of merely 1,188 kilometers, Pluto is dwarfed not only by the major planets, but even by some of their moons. In terms of mass, it tips the cosmic scales at just 1.3 times 10 to the power of 22 kilograms, a mere 18% of the mass of our very own moon. This is why in 2006, Pluto was reclassified as a dwarf planet, a celestial category that suits its petite stature. Pluto's peculiar orbit takes it on an exhilarating cosmic ride. In 1989, it reached its perihelion, the closest point to the Sun in its orbit coming as close as 29.7 astronomical units. Since then, Pluto has been gradually distancing itself from our blazing star on a trajectory that will reach its zenith in the year 2113, at an aphelion of 49.3 astronomical units from the Sun. These vast distances cast Pluto into mysteriousness, rendering it invisible to the naked eye from our Earth, and even when viewed through the lens of the Hubble Space Telescope. The Hubble Space Telescope, a joint endeavor between NASA and the European Space Agency, has been our cosmic peephole into the universe since its launch in 1990. One of Hubble's remarkable achievements has been the capture of deep-field images, unveiling galaxies, nebulae, and remote objects in unprecedented detail. Moreover, Hubble has lent its watchful eye to our solar system, studying planets, asteroids, and comets, including Pluto. To unveil the secrets concealed within Pluto's icy heart, humanity launched the New Horizons spacecraft in 2006. This bold mission aimed to provide us with our first close-up glimpse of Pluto and its entourage of moons. After a nearly decade-long journey, New Horizons finally reached its destination in 2015. As New Horizons zipped through the Pluto system, it flashed back more than 6 gigabytes of data collected from around 400 observations. These observations included high-resolution images, spectral data, and invaluable insights into Pluto's composition, geology, and atmosphere. This extraordinary mission marked a significant leap in our understanding of Pluto and forever altered our perspective of this remote world. But we can't talk about Pluto without trying to understand what its internal structure looks like. Pluto harbors a complex and captivating internal structure beneath its icy surface. At its core lies a substantial sphere, approximately 1,700 kilometers in diameter. This core is a mixture of various forms of water ice and rocks. Wrapped around this essence is a 300-kilometer thick iced mantle, where mysterious tectonic processes may be at play. Enveloping the mantle is a crust composed of crystallized gases, including nitrogen, methane, and carbon monoxide. One of the most intriguing aspects of Pluto's internal makeup is the tantalizing possibility of a subsurface ocean. Some theories made it known that Pluto's core generates sufficient heat to partially melt the icy mantle, creating a briny and toxic ocean hidden deep beneath the surface. This hidden ocean could hold invaluable clues about Pluto's history and evolution. But there's more to Pluto. Another of our explorations of Pluto's enigmas commences with a focus on its surface features. Tombaugh Regio, the most prominent feature on Pluto's face, is similar to a heart-shaped puzzle piece. It covers roughly a quarter of Pluto's surface, spanning an astonishing 2,300 kilometers. In the west, there's this smooth and light area called Sputnik Planitia. It's like a giant plane, stretching 1,499 kilometers wide. But if you could look at an elevation map, you'd see that it's a huge lowland. What's really cool is what covers this region: a thick layer of nitrogen ice, carbon monoxide, and solid methane. These substances are kind of light in color, which makes parts of the plane reflect up to 90% of the light that hits them. But here's the kicker: there aren't many craters there, which means this place is relatively young in terms of geology. The leading theory is that Sputnik Planitia came to be about 100 million years ago, when Pluto got into a bit of a cosmic fender bender with a big space rock. This collision left behind a massive impact crater, and the stuff from Pluto's supposed internal ocean quickly froze inside it. Now, if you check out the terrain, you'll see some interesting features. There are these smooth, flat areas, about 20 to 30 kilometers in size, with hills and depressions along their borders. It's kind of like how liquids form convection cells when heated from below. Encompassing Tombaugh Regio, we encounter towering mountain ridges such as Hillary Montes to the west and Tenzing Montes to the south. Some of these peaks tower over 6 kilometers in height and are primarily composed of water ice. In the extreme cold of Pluto's environment, water ice takes on the hardness and solidity of rock, chiseling rugged landscapes. As our cosmic journey continues southward from Tombaugh Regio, we stumble upon a profound basin encircled by massive terraced ridges comprised of ice and rock. This basin is the vestige of an ancient Cree volcano, with the terraced ridges representing frozen leftovers of volcanic eruptions. The chemical composition of these formations harbors profound scientific interest, offering potential clues about Pluto's mysterious interior. Moving further eastward along Pluto's equatorial belt, we come face to face with a series of enigmatic dark spots, each stretching hundreds of kilometers in diameter. These dark spots, collectively referred to as maculas, bear names inspired by dark deities from various cultures. Together, they merge into a structure known as the brass knuckles, encircling Pluto's equator. The maculas are separated by towering mountain ranges and deep abysses, creating a diverse and intriguing landscape. Pluto's surface, as revealed by the maculas, showcases its geological complexity, with a variety of terrains and features awaiting further exploration and analysis. As we journey northward from the equator, we encounter Lowell Regio, a vast valley that surrounds Pluto's North Pole. Surprisingly, this region stands out as one of the most illuminated areas on Pluto's surface. The unique brightness of Lowell Regio is due to Pluto's axial angle, which positions its north pole toward the Sun during its orbital journey. This alignment with the Sun has led to an intriguing phenomenon. Despite Pluto's increasing distance from the Sun, the density of its atmosphere has tripled over the past 30 years. This intriguing observation suggests that the Sun's rays may be evaporating nitrogen ice from Pluto's surface, which then settles at the pole, contributing to the dwarf planet's atmosphere. Before we delve deeper into the mysteries of Pluto's surface, let's take a moment to understand Pluto's unique orbital behavior. Pluto's orbit exhibits a noticeable angle relative to the plane of the solar system, and it continually swings near a specific point in its orbit. This peculiar behavior is a consequence of the gravitational influence of its largest moon, Charon. Speaking of Charon, this is Pluto's largest moon, which possesses a significant mass measuring 1.52 times 10 to the power of 21 kilograms. This mass is more than 11% of Pluto's total mass. The gravitational interaction between Pluto and Charon results in a remarkable allure between the two celestial bodies. Both Pluto and Charon are totally locked to each other, meaning they always present the same face to one another. This simultaneous rotation is a common occurrence in binary systems like Pluto and Charon. As they orbit a common center of mass between them, they always maintain their relative positions. One of the most notable features on Charon's surface is the massive Vulcan Planum, a region south of the equator, Within Vulcan Planum stands Kubrick Mons, a towering mountain with a diameter of approximately 40 kilometers. Some estimates suggest that Kubrick Mons reaches a remarkable height of 4,000 meters. This mountain's enigmatic formation includes a wide circular moat, possibly indicating cryovolcanic activity. To the north of Vulcan Planum lies Oz Terra, a vast expanse marked by numerous craters. It is separated from the Vulcan Planum by a system of towering ledges and chasms with a total height of about 1 kilometer. Serenity Chasma, a massive chasm stretching over 200 kilometers in length, adds to the complexity of this region. The vertical slopes of this abyss create challenging conditions for exploration, as shadows cast by the rugged landscape obscure visibility. Further north near Charon's pole, we find the massive Mornar Macula, with a diameter of approximately 475 kilometers. The origin of Mornar Macula remains the subject of debate among scientists. One prevailing hypothesis suggests that nitrogen and methane escaping from Pluto's atmosphere become trapped at Charon's poles, where they gradually turn into tholins, dark organic molecules. These tholins then accumulate in Charon's ice, contributing to the dark coloration of the region. Charon is not the only satellite in Pluto's orbit. Pluto's system of moons also includes several smaller, irregularly shaped companions, each with its unique characteristics. Among these are Nix and Hydra, discovered in 2005, and later findings such as Kerberos and Stax. These celestial bodies primarily consist of water ice and were likely captured by Pluto's gravity from the Kuiper Belt, a region of the solar system beyond Neptune, populated by icy bodies and dwarf planets. The Kuiper Belt is a region of the solar system that harbors countless small objects. Pluto's residence within the Kuiper Belt provides invaluable clues about its origins and evolution. The Kuiper Belt, similar to the asteroid belt, but much farther from the Sun, is a treasure trove of icy remnants left over from the early days of our solar system. It is home to a diverse population of celestial objects, including comets and small planets. This cosmic zoo offers a glimpse into the conditions that prevailed during the formation of our solar system. Pluto's existence within the Kuiper Belt raises questions about its origin. But did it form here, among the frigid realms of the Kuiper Belt, or was it once part of the inner solar system, expelled to the outskirts over cosmic ages? Astronomers have continued to investigate these intriguing questions. Our cosmic journey to Pluto is far from over. While the New Horizons mission provided groundbreaking insights, the mysterious dwarf planet continues to beckon us. The future holds exciting prospects for Pluto exploration, with new missions on the horizon. One such mission currently in the conceptual phase is the Pluto Kuiper Express. This ambitious mission aims to build upon the successes of New Horizons by conducting a more comprehensive study of Pluto and its moons, including Charon. With advancements in technology and our ever-growing thirst for cosmic knowledge, the mysteries of Pluto are poised to yield even more profound revelations. As we draw the curtains on our cosmic journey to Pluto, we are reminded of the unquenchable thirst for knowledge that drives humanity's exploration of the universe. Pluto, with its unique characteristics and mysteries, serves as a testament to the beauty and complexity of our solar system. What are your thoughts about this planet? Let us know in the comments section below, and don't forget to like and subscribe to our channel for more updates on space. Thanks for watching.